Variables and expressions. In order to get started, let's take a look at some examples. So 5 plus square equals 12. That square is doing a job and it's holding a spot of a number. And this is a problem you may have seen in first grade, and you would have been thinking 5 plus what equals 12? Simple enough. You're just trying to fill in that square because you already knew back then that that square was holding the spot of a number. Then as you got into third grade, you may have seen something that looks more along the lines of 8 times question mark equals 32. Instead of a square, now it was a question mark. Same thing, that question mark is still holding the spot of a number. Check this one out. 24 divided by star equals 6. Now that's not as common, but that star is still holding the spot of a number. It could be anything. It could be a heart, it could be a diamond, whatever symbol or shape you want. It still is holding the spot of a number. However, moving forward, we are going to see not stars and question marks and squares. We will see letters, just like X here, to hold the spot of numbers. And all of these have a special name. These symbols are called variables. And so we could basically define variables as symbols, which are usually letters, that hold the spot of numbers. Next, we'll take a look at expressions. There are two types of expressions. One you're very familiar with, which is a numerical expression. Notice in the example it shows 2 times 3 plus 4. It consists of numbers and operations. That's it. There's no more to it. Now, the other type of expression, an algebraic expression, has one added component. There's still numbers and operations, just like with the numerical expression. However, this one has a variable with it as well, which is represented by the y. Now, when working with algebraic expressions, multiplication can look quite a bit different. So I have a little alert here for you to show you the differences. With numerical expressions, we may see a problem that looks like this, 3 times 6, where that x is a symbol. That symbol is the most common multiplication symbol for numerical expressions. However, this symbol does not work for algebraic expressions because it can be mistaken for the letter x. So what do we do when we are looking at algebraic expressions? What symbols are used? Well, instead of an x, a dot can be used. So 2 dot y, for instance, would mean to multiply. Another way you may see is without any symbol at all. No symbol, no space. They're right next to each other. That's multiplication. The only thing you need to be cautious of is to always put the number first and then the variable. If we put the variable first and then the number, that would not work. For instance, y2 is not acceptable. It would have to be 2y. The last way to write a multiplication for algebraic expressions is to use parentheses. You can just use one set of parentheses or 2 sets of parentheses. And if there is no symbol in between the parentheses and the number, as right here, it just means to multiply. Now that we have the little tidbit about multiplication taken care of, what we're going to move on to next is looking how we can take math words and turn them into algebraic expressions. For example, let's say we see some math words like the sum of x and 3. How do we take those words and turn them into an algebraic expression? Well, we know that an algebraic expression has 3 parts. It has a number, a variable, and an operation. Well, the number and the variable are easy to point out here, but where is the operation? If you happen to know your math language, you would know that sum refers to addition. So we would have x plus 3. Before we end up going ahead and doing some of these, let's take a look at some different words for each of the operations, starting with addition. First one is plus, more than, increased by, sum. For subtraction, there are several. Minus is one of them. Less than, fewer than, decreased by, difference. For multiplication, there's times and product. And finally, division has divided by and quotient. Now this isn't a complete list, but these are very common words for each of the operations. Using this list, we can now take these words and turn them into algebraic expressions. So let's start off by looking at a few practice problems. 5 times k. Well, times is a pretty easy one. We know that being to multiply. So remember, we do not write it using the little x symbol. We could write it with a dot, so 5 dot k, or just put 5k for multiplying, and we could even use parentheses. There's a few different options. The same thing is true for the next example, f divided by 2. The common way to write it would be f with the division symbol 2, but we're going to see in algebra that it is written more often as a fraction, because fraction means division. This next example is a little trickier. 7 more than x. Well, more than means to add, so you think, oh, 7 plus x. And that would work to get you the right answer, but technically it would not be written the correct way. So think of it this way. Let's say you have a wallet and there's some money in it, but you can't remember how much money is in your wallet. That would be X. You have X number of dollars in your wallet. But then your parents give you $7 more. So now you have the X plus $7 more. So we're going to put the 7 at the end of the expression because that is what was added to the original amount. So this would be X plus 7. D, it says a number y decreased by 17. Decreased by is subtraction. Y minus 17. And the last example in this section, 11 less than 4 times w. Notice it shows less than here. This is very similar to more than. We'll need to put the 11 at the end. What do we start with? We start with 4 times w, and then we have 11 less than that amount. So we'll write it as 4w minus the 11. This is the most common mistake people make when writing algebraic expressions. So make sure that whenever you see words like less than, more than, fewer than, always put that at the end of the expression instead. Lastly, we're going to go in reverse order. So we'll look at algebraic expressions and turn them into phrases. So I'll do a few examples. First one, 12 and the addition sign t. Since we know it's addition, we could look at the addition box and choose a word or phrase. I'll start with sum. Sum of 12 and t would be a phrase to represent that expression. We'll do another one. This time I'll choose more than. Now it has the word than in it, so remember that whenever it has the word than in it, we need to flip them around. So instead of 12 more than t, we start with t and we have 12 more than that. So it'll be t more than 12. Problem B, 8x. Well, when the number and the variable are right next to each other, that's multiplication. So we could look in the multiplication box and it shows two words, times and product. So we could say 8 times x. And if we use the word product, it would just be the product of 8 and x. Problem C. U, subtraction sign, 5. We go really basic and just say u minus 5. Let's get a little more challenging and use one of these than words. I'll choose fewer than. Remember, using the word than, we need to flip them around. So we start with 5, but then we have u fewer than that. So it would be 5 fewer than u. For the last problem, we have 3x minus 2. Now notice there are two operations here. 3x representing multiplication and minus 2 for subtraction. So we will make one phrase to get both of those in there. I'll choose for subtraction, I'll do less than, and for multiplication, times. So if I'm using less than, I need to go in reverse order. So we have 2 of something and 3x less than that. So I will go 2 less than 3 times x. And one more example, I'll go in the regular order because I'm not going to use than for subtraction. So 3x. I could say the product of 3 and x and minus 2. The product of 3 and x minus 2. And that concludes the lesson.